So for this video, we're talking about density.
What is density, Ms. Vaught?
Well, density is the mass per volume.
What?
So basically, it's how much stuff an object has in its set amount of space.
Oh, so does everything have the same density?
No, it doesn't. For instance, if you had a block of wood and a block of metal, and they were the exact same size blocks, okay, which one do you think would be more dense?
The wood.
Well, not so much. Because obviously if you're holding these in your hands and they're the exact same size, the metal one's going to feel heavier, right?
Yes, you're right.
Theoretically. Okay, so the metal is probably going to be more dense than the wood.
So that means the metal has more stuff packed into it than the wood does?
Yes.
Oh, okay.
For instance, take this paper towel roll. Okay, right now it's empty, so it has no density, right? But I can give it density by shoving stuff inside of it. And how much toilet paper I shove in it depends on is making it more dense, right?
Yes.
Okay, so how much toilet paper I have in my paper towel roll is how dense it is. Okay, so if I cut this paper towel roll in half, toilet paper roll, do you think the density will change?
Well, let's think about it. You didn't stuff any more stuff inside here,
No, I didn't.
so I think it stayed the same.
That is correct. I didn't put anything else in, I didn't take anything out, so the density actually didn't change. Therefore, density is an intensive property.
Oh, okay.
Okay?
Mr. Thompson taught us that, didn't he?
Yes, he did.
Okay, so the formula that we use for density is density equals mass over volume. And once we have that formula, we can go ahead and assign some letters. So density is going to be a capital D, mass is a lowercase m, and volume is a V. Okay? So once we have that recorded, there are a couple different things that we can do to help us remember this formula. So density equals love. So if we have a heart, the heart gets shot with an arrow. Okay? Well, here's your mass, here's your volume, equals your density. Okay, so that's just a little cute way to help you remember your density formula.
Okay, so we know we need the mass and volume of an object to find its density, right?
Yes.
So we're going to go ahead and find the density of this block. Okay, so what do I need to do to find its mass?
We need to put it on the scale,
Okay,
and the scale says that it's 53.1 grams, so I'll record my data.
all right. So now we need its volume. How do I find the volume of a block?
It's length times width times height. Is that right?
Also works for geometry, but yes.
Yes.
Okay, so let's go ahead and measure its length, width, and height. So if I have a length, width, and height, what do I do with them?
Multiply them.
Let's multiply them all together. Okay, this will give us our volume. And then I can simply put it into my D equals M over V formula.
Okay, so now that we have all of our measurements for our cube, we can take our length, width, and height and find our volume, because we know that length times width times height is equal to volume. So our length is 4.2, our width is 2.4, and our height is 4.5. And so I simply multiply all three of those together, and my volume is going to be equal to 45.36. Now each of these was centimeters, so if I multiply centimeters times itself 3 times, it's centimeters cubed. Okay? So that is our units for this particular volume. So now that I have my volume and my mass, I can plug it in to my density formula. So density equals mass over volume. So my mass was 53.1 grams and my volume was 45.36 centimeters cubed, which gives me, once I put that into the calculator, 1.17 grams per centimeters cubed. Okay, so density could be grams per milliliters, or it could be grams per centimeters cubed, depending on if you were looking at a liquid or a solid substance. Okay, so we just found the volume and density of a block. Okay, but what if we had something that doesn't have all those nice sides to measure, say like a marble? Okay, so if we have a marble, I don't have a length, a width, or a height that I can measure for this to find out its volume. So what I can do is I can take a set amount of water that I do know the volume for, and I can use that water to figure out the volume of my marble. For instance, if I have water that is at a set height, let's say it's at 20 milliliters, and I add my marble to the water, then the water is going to go up. Okay, so now my water level with the marble in it will rise. Okay, and let's assume it could rise as much as 24 milliliters. So the amount that it changed is actually the volume of the marble. So 24 minus 20 would mean that the volume of the marble was simply 4 milliliters. Okay, this is just an example, but you could use this for any irregularly shaped object that doesn't have a set length, width, or height to measure. So we're going to go ahead and take a marble, and we're going to find its volume for you so that we can do another density problem.
So our volume should have changed with the marble in it.
It looks like 19 to me.
Looks good.
Okay.
Okay, so our marble made the volume of the water change. So the difference in the water is going to be the volume of our marble.
So I'm supposed to do 19 minus 14?
Yes.
So it has a volume of 5 milliliters?
Exactly.
Okay.
Okay, so our marble has a volume of 5 milliliters. Okay, so now we need to get our mass of the marble.
30.1 grams.
That would be 31.1.
Oh, 31, sorry.
There we go. All right, so now we have our mass and our volume of our irregularly shaped object. We can do D equals MC over, D equals M over V. There we go.
Okay, so the mass of our marble was 31.1 grams, and our volume after the water displacement ended up being 5 milliliters. So if we put it into our density formula, I have a mass of 31.1 and a volume of 5 milliliters. Okay? So now all I have to do is divide. So we plug in 31.1 grams divided by 5 into the calculator, and our density is 6.22 grams per milliliter. Okay? So that's pretty straightforward. If you wanted to use a different method to solve for this, we do have a triangle that you can put the formula into. Density equals mass over volume. To use the triangle, we simply plug in the numbers that are given to us. So our density, we don't know. Our mass, 31.1 over 5. And we can simply divide 31 by 5. And again, get the exact same answer. But this is a division. If you're doing one that goes this way, it's multiplication. Okay? So that's our wrap up for density. We know that density is equal to mass over volume. Density is an intensive property. Mass is always going to be in grams. Volume could either be in milliliters or centimeters cubed. So when you combine the two, your density units are always grams per milliliters.
Well, I can find the volume of anything by dropping it into water and being able to measure the difference in the volume.
Pretty much.
So what is the density of water?
Well, the density of water is actually 1. So anything that's heavier than 1 is going to sink. And so we can totally do the water displacement.
But what happens if it doesn't sink? Like wooden boats, those don't sink.
Well, let's find out. Oh. Okay, well, so obviously there's not going to be much of a water difference if it's not sinking, right? That's because the piece of wood actually has a lower density than the water.
So that means that it's got a density less than 1?
Exactly. A density greater than 1 is going to sink. A density of less than 1 is going to float. It's buoyant.
Oh.
And
I
that's
remember
buoyancy.
buoyancy.